sequences, we're going to learn about another type of sequence that we call a geometric sequence. And a geometric sequence is a sequence that multiplies by the same number each time. So instead of doing plus 3, plus 3, plus 3, it's doing times 3, times 3, times 3. And that number that we're multiplying by is called the common ratio. So the number being multiplied. And so to find the common ratio, you can take any term divided by the previous term. And that'll tell you what's being multiplied. Sometimes you can just tell. Sometimes it'll be like a fraction. Like you can multiply by 2/3 and your number will get smaller. So that's possible. You can multiply by a negative number. That's possible. Okay. So the first 6, we are going to determine if it is geometric. So are we every time it is the common ratio. Number 1, from 6 to 12, what do I do? Times 2. What is 12 times 2?
24.
Is 24 times 2 48?
Yes.
Yes. So yes, it is. And so R equals 2. Now on number 2, my numbers are getting smaller. So it's going to be a fraction. So if you say, okay, well, I don't know. If you go type in 270 over 810, I get 1/3. Okay, let's try all the others. 90 over 270. Yep, it's 1/3. 30 divided by 90. It's 1/3. Technically, we're dividing by 3 every time, but we don't use divided by. It always has to be multiplied. So dividing by 3 is the same thing as multiplying by 1/3. So yes, it is geometric, and my R is 1/3. Number 3. Am I multiplying by the same number every time?
-5.
Yes, I am, and it is -5. If your numbers go negative, positive, your ratio is a negative number. What about number 4?
No.
No, because this would be times 2. 8 times 2 is not 20, so that's just no. What about number 5?
Is it divided by -4? Or
It's okay, so we are dividing by -4, but that cannot be a ratio. So how would I write that as a multiplication? -1/4. Yes. So my R is -1/4.
Can we do a decimal or
Yeah, you can do either. For example, on number 2, 1/3 is a repeating decimal, and so you cannot do 0.3. You have to leave it as a fraction. But if it is like negative 0.25, that's okay. I will always use a fraction. So, unless, well, it can't be a fraction, so. All right, number 6.
Yes.
Yes, no? Okay, let's just try. 8 over 3.2. Okay. 20 over 8. 5 over 2 is 2.5. And 50 over 20. Yep, it is. The ratio is 2.5 or 5 halves. Okay. So just like with an arithmetic sequence, we have a formula that we use to find any term in the sequence. And so we still use AN. That just can represent any term in the whole list. Okay, equals, it's A1 times, we put our R in the parentheses and we give it an exponent, n minus 1. And again, what is my A1?
The first one.
First term. What's my R going to be? Well, what's it called with geometric?
Common ratio.
The ratio, yep. The common ratio. And then n, if it's the 5th number in the list, my n is 5. Now these, we don't have to do any kind of distributing or anything. So writing these equations is actually a little bit easier. So number 7, I'm going to write my rule first. So it's A1, which is what? 1 times, what's my R? 5 to the n minus 1. And now we do want to simplify this a little bit, meaning if I'm multiplying by 1, you don't really need to put that. If my ratio is a positive number, it can go in parentheses, but it doesn't have to. So you might see it like that. If your ratio is negative, you absolutely have to put that in parentheses. And then we're going to find A7. Now with geometric sequences, they tend to get your numbers, you're multiplying. So your numbers are going to get pretty big pretty fast. So it's okay if you see big numbers on these. A7 is 5 to the 7 minus 1 power. And when you type that in your calculator, you can just do 5 to the 6 power. You don't have to put 7 minus 1. And so the 7th term, if I went out 3 more times, it would be 15,625. Number 8, my formula is A1, which is what? 130 times my R, yep, 0.5 or 1/2. When I'm asking you to write the rule, you can assume that it's going to be geometric. You don't have to go and check every single ratio to make sure. Only when I'm asking, is it geometric, yes or no. Here's what a lot of people want to do. A a lot of people say, okay, well, 130 times 0.5 is 65. And they want to write 65 to the n minus 1 power. But that is not correct. This n minus 1 power is only applied to the 1/2. It's not applied to the 130. Your exponent rules don't work that way. So you just leave them separate. Okay. So it's just 130 times 1/2 to the n minus 1. That's all you have to do. You can leave the 1/2 in parentheses. You don't have to. The sixth term would be 130 times 1/2 to the 6 minus 1 power. And I want you to write the whole thing. Unless it's like 50 decimals long, but you can write 4 decimal places. Try number 9. The formula is 2 times, in parentheses, -4 to the n minus 1 power. And then my 8th term is -32,768. Are there any questions?
Wait, what's that?
-32,768. There are 3 more just like this, so I want you to work on those 3. Alright, so number 10, the 6th term should have been 1,944. The 11th term, or number 11, sorry, the 7th term, you got a pretty long decimal. So if you round that, it would be 11.852, or you could have converted it to a fraction in your calculator to get 320 over 27. And then number 12, you got 25 over 8 for your 6th term, or 3.125. Are there any questions? Yes.
Do we always have to turn those into like fractions?
Not necessarily. You can, a decimal's okay usually.
Is there a way to change decimal into a fraction?
Mm-hmm. Yep. So if I have, let's see, if I have 2.5, if you hit math, there's a couple of ways, but the one I think is easiest, math, enter, enter. Or alpha y equals that number 4 will also do it. Alright, so numbers 13 through 15, we're going to be looking for some missing terms, filling in the blanks, and finding the common ratio is a little bit different than the difference. It's a little bit harder. It involves square roots, cube roots, fourth roots, but your calculator does all that for you. So when we're finding the common ratio and we're just given 2 terms, let's call this A4, A5, A6. I just picked 3. I have 3 terms. I just picked 3 consecutive. I could have picked a 1, 2, and 3. It doesn't matter. So my common ratio, it's going to be a root, but it's not necessarily a square root. It's whatever 6 minus 4 is. That's 2. That is actually a square root. And then under the root, I do 100 divided by 4. So if you go to math on your calculator, if you go to number 5, you can type in any root that you want. So you can just do the 6 minus 4. And then under the root is 100 divided by 4. And so that tells me that my ratio is 5. Meaning to get to each next term, I'm multiplying by 5.
Like, how do we do that on our calculator?
It's under math and then number 5.
Oh.
So this equals 5. Now again, you could probably just try 4 times 3 times 3, 4 times 4 times 4 to see what numbers worked. But what if your ratio was a fraction or a decimal? You might take a long time to find it. So what is 4 times 5?
20.
Is 20 times 5 100?
Yeah.
Yes, it is. Okay. So number 14, let's just go ahead and label these terms. I can call them A1, A2, A3, A4. It doesn't matter. So on this one, my root is going to be 4 minus 1, which is 3. So no matter which 4 terms you used, you would have a cube root there. You would have a 3. And then it's going to be 13.5 divided by 4. So your ratio is 1.5, or you can write it as 3 halves. So then I do 4 times 1.5, I get 6, times 1.5, 9, times 1.5 is in fact 13.5. Are there any questions? I want you to try number 15. Number 15, you should have your R equals 5, which means your blanks would be 10, 50, and 250. Any questions? Okay. All right, let's go down to number 16. So on this one, I'm given a random term, my ratio, and I'm asked to find the first term. So I could write these out and then work backwards. I could divide by 4 each time to work my way backwards, but I'm going to show you how to do it with the formula. So remember our formula, AN equals A1 times R to the n minus 1 power. Am I given a term in the sequence? Yep. I'm given A8. So, and I know that A8 is this 114,688. What I don't know is my A1. My R is 4. Do I have an N right here? It's 8, because my 8th term is this 114,000. And I can just type this in the calculator, the 4 to the 8 minus 1, and that's what I get. $16,384. Now, how do I get the A1 by itself? Divide. Yep. We get 7. And then ask for A1. That's what we got. Number 17, I am given the fourth term, and I'm asked to find the third term. What piece of information do you think that I should probably find? The ratio, yeah. So to find that common ratio, I can use this root formula that I used up here. So I'm going to be finding the third, or the cube root, because 4 minus 1 of 4,459 divided by 13, which is 7. So my common ratio is 7. Now, if I'm given the fourth term, what would be the easiest way to find the third term?
Take 7 and
Divide by 7. We're just going backwards once. We just got to divide by 7 once. So we'll do that. That is the easiest. So if I do 4,459 divided by 7, we get 637. Now, if I had given you some way off one to find, we would have to go back to the formula. We would plug in my 13 for A1, we'd plug in the 7 for the R, and then I could for the N. So I could have said, well, it's A1 times R to the 3 minus 1. Whoop. Let's calculate it. And I got 637. So either way would have worked. So I want you to try number 18. Alright, so for your ratio, you should have 0.2. And then I just said, well, I'm finding the term before this one, so I divided by 0.2. I could have started at 6 and did 6 times 0.2. That would have been the third term. Times 0.2 would have been the fourth term. And I get 0.24.
If we did the equation, we would have had to find A1.
Yeah, if you wanted to go back to the equation, you would still have to figure out A1.
Because that's what I did. I just did 6 divides.
Yeah, that would have worked too.